Okay, so we finished another section of content. We're getting close to the end.
Mommy?
Yeah?
Is the apocalypse happening?
Not yet, but if it did, it might start with math, which is where we're going next. Getting close to Halloween, things are going to get creepy. So let's do some more dosage calc. So because we dealt with pain in the last video section, we're going to start with a pain medication. And this is going to get scary because we have to do some conversions. But Halloween is coming. So our order is for ibuprofen. Sorry, let me move that up there. 600 milligrams. Kind of a large dose, but not unheard of, especially in an adult inpatient unit. However, your patient can't swallow pills. Excuse me. Honey, I need you to be a little bit quieter, okay? It comes supplied as these little cup jobs here, called unit dose packages. You need to note two things on here. Let me get that up here. First, that you have 200 milligrams in a 10 ml solution, and next, that your package has 10 mLs. Okay, so I'm going to restate that for you. Give me 1 second. So here we are. I restated it. 200 milligrams equals 10 mLs. 10 mLs equals 1 unit dose package. And because we're nurses and we're concerned with realistically what dose are we going to give and what's that going to look like, we want to know how many unit dose packages are we giving for this patient, right? Okay, so let's clean that up a little bit and set it up in dimensional analysis. And in dimensional analysis, you know that we begin with the end in mind, or we start where we hope to finish. And we want to know how many packages equals a dose, right? And we want our dose on the bottom. And we know that our dose is 600 milligrams. That's what was ordered. And now we want to have our package on the top. So a package equals 10 mLs. But that's not going to do us any good because we now have to get rid of mLs and we have to get rid of milligrams. So let's go ahead and set that up so it'll cancel out. We know that 10 mLs equals 200 milligrams. Now those of you who are really comfortable with fractions might look and go, well, 600 goes into 200 3 times, I could cancel those out, and 10 goes into 10 once, so I'll cancel those out. But some of you aren't comfortable with fractions, so we're going to go ahead and do it the long way, multiply across. First thing we need to do, make sure we set it up right. Milliliters cancels with milliliters. Milligrams cancels with milligrams. We are left package per dose, which is what's in our answer. We know we set it up right. Go ahead and multiply it across. You'll end up with 6,000 packages, yep, over 2,000 doses. It's a crazy number. Now, if you need to use your calculator for that, have at it. If not, you know what I do is simply cancel my zeros out. 6 goes into 2 3 times, and I know I need 3 packages, which is the correct answer. You are going to use 3 of those little unit-based package cups of medication to give a 600 milligram dose. So that was a little more complicated than what we did in the last video, but not really all that scary. So let's see what we can do to give you a good thrill. Okay, so this is really, really scary. I threw in a lot of stuff. You might have to watch this one more than once. Ooh, boo. Well, it is Halloween, so here's what I did. I not only took a dosage calc problem for this, which is scary enough because it's math and everyone hates it, unless you're weird like me. But I also turned it into a weight-based problem, and I was really, really evil, and I made it a kid, and that's why I gave you a tombstone, because kids come in all different sizes. There's really no standard dose that says, whoa, that's a lot of medication, or that just seems like not enough. It doesn't seem right. You can have a preterm baby who weighs less than 1 kilo. You can have an obese adolescent who weighs more than 100 kilos. So anywhere in between that, if you have a weight-based dosage, and most peds drugs are, you just have to do it right, or you could kill somebody, hence the tombstone. All right, so let's get working. We're going to put that up there. We're going to get rid of this. And dimensional analysis is really useful because you can do these really complicated problems. Let's take a look at our drug label and see what it looks like. There we go. And I'm going to highlight what I think is important here. And it is this 10 milligram per ml. Okay, now I can shrink it. So now you know you have a kid who weighs 22 pounds, you have a med that's 10 milligrams per milliliter, And now you have to set it all up so you know how many milligrams per kilogram is in the ml that you want. It gets kind of complicated, but let's break it down, make it really super simple. I'm in the med room. I'm drawing this med up into a syringe to give an IV push medication. I need to know how many mLs goes in the syringe. Does that not make sense, right? Because that's what I've got and that's what I'm working with. So let's know what our mLs per dose is. Let's start where we hope to finish. Begin with the end in mind. Always with dimensional analysis, start with the answer and work back from that. Okay, so anything that's mLs goes on the top. Well, that's easy peasy. I know that 1 ml of medication, because I looked at my drug label. I'll show it again, 10 milligrams to an ml. Okay, sorry, is equivalent to 10 milligrams, right? Makes sense so far. Now it's going to get a little tricky because now I have a kid who weighs 22 pounds and I need milligrams per kilograms to get my dose. But let's try and keep it a little bit simple and put our dose on the bottom. And our dose happens to be 2.5. Make that decimal nice and large because we are dealing with kids. That's important. People have killed kids without that, with the wrong use of decimal point. Just saying. I have a great story for that if you ever want to know. Okay, so we have that. Oh, wait, we have something over something over something. How do we get rid of that? Very simply, we'll put it down here. Okay? If it's on the bottom, it's on the bottom. It goes next to the dose. Okay? So now we got to get rid of the kilograms. We have a patient that weighs 22 pounds. We know that 1 kilogram. Whoops, nope, we want that to cancel, right? Okay, no biggie. 1 kilogram equals 2.2 pounds. Again, be careful with your decimal places. Okay, but now we have kilograms. Now we have to get rid of pounds. We have a patient who weighs 22 pounds. Okay. Okay, so now we're ready. Let's see if we set it up right. Cancel pounds. Pounds goes away. Cancel kilograms. Kilograms goes away. This already kind of, we put it down twice, so it doesn't count. Cancel milligrams. Milligrams goes away, and we're left with ml per dose. And now what you can do is go straight across, right? And what you're going to end up with, give me 1 second so I can clean this up a little. Okay, and here I just multiplied straight across for those of you who can't handle reducing fractions. I know some of you looked at that and said, wait a minute, that was really easy without doing all the math. But if you multiply straight across, you get 55 over 22. You do that division and you end up with 2.5 mLs per dose, okay? Now some of you, I know, looked at this. Hold on, let me kind of get rid of that. Some of you looked at this problem and said, wait a minute, this is really, really simple because you have 22 over 2.2, that'd be 10 over 1. Here, let's do that. 22 with 10 over 2, you get 10 here. Now you have 10 here, 10 there, you could cancel that, and you end up with 2.5. If you're great with fractions and you know how to reduce and simplify, you could have done this a lot faster. You would have ended up with the same dose. If not, go ahead, multiply it out, use your calculator, divide that 55 by 22 to get your 2.5 milliliter dose. But the bottom line in all cases is that you end up with 2.5 milliliters per dose. That is what you are giving IV push. If you end up with anything else, you did it wrong. And I'm just going to tell you this. There are 3 different ways that I know of, and probably a few invented ones, to do dosage calc problems. For me, it's sort of like if I tell you that we need to meet at the mall at 8 p.m. and I give you a set of directions and you say, you know what, I know a different way and I like that way better. I'm okay with that, but you better be at the mall at 8 o'clock. Okay? That's sort of where I'm headed with this. If you saw a way to do this that made sense to you and you still ended up with 2.5 mLs per dose, good on you. Keep doing that. If you ended up with any other number, whatever method you used, you need to rework that problem, okay? Because that's how you kill people. And on that cheery note, I'm going to wish you all a pleasant Tuesday morning, which is when I will see you next. Bye.